And non-destructive testing has been around for many, many, many years in simple forms. And this is a form which is quite, we'll come to in a minute. But one of the challenges that we had is working with non-mechanical materials. Biological materials are a great challenge, and we had many discussions around the mechanical properties of bone, which is very complex. It's not linear elastic, it's non-homogeneous, and it's non-isotropic. It's very difficult, and it not only varies in structure and relative ratios of density in different parts of the body, also, especially and very importantly with dental implants, the interface changes. Clinical osseointegration is a biomechanical phenomenon. Primary implant stability is like putting a screw in a piece of wood. Secondary implant stability is something magical. And that is what we'd like to be able to measure and to understand. So that is not a simple thing to do. And as we can see, the structure of bone is so different, even in quite close proximity parts of the mouth. And to be able to manage that was an important and essential part. The other problem was size of scale, as I alluded to. And we talked about early non-destructive testing. The wheel tapper was a very, very important part. And this very skilled gentleman simply tapped a wheel and elicited a ringing sound, not just a pure ringing sound, but with harmonics. And by a wealth of experience and a very delicate ear, was able to perceive and understand if there was a crack in the wheel, and thereby predict and avoid failure. What Peter and his team were part of modern non-destructive testing was the developments of technology and techniques which enabled accurate and precise measurements to be made to understand where and how flaws and areas of concern in materials and equipment could exist, and thereby prevent failure.